one of the important parameter in relevance to antennas because the intensity of the radiation by which an antenna can radiate is an important parameter for the antenna. So in today's session, you learn about the one more important basic antenna parameter, that is radiation intensity. It is defined as the power radiated from the antenna per unit solid angle. So radiation intensity of an antenna is defined as the power radiated from the antenna per unit solid angle. And the maximum power that can be radiated depends upon what is the type of source. In earlier sessions, we have learned about the isotropic source and omnidirectional source. So normally an isotropic source is used for an antenna so that the maximum signal is obtained by the antenna. So what are the percentage of signal that is radiated? It is called as power radiated from the antenna per unit solid angle. And the units for this radiation intensity is watts per steradian. The watts per steradian is the unit for radiation intensity. And always the radiation intensity depends upon what type of source it is, whether it is an isotropic source or as whether it is a non-isotropic source. And the radiation intensity is written as U, where U is equal to R square into S radian. Means R square is the total radius and S radians is the maximum power radiated. And radiation intensity is expressed as U. And the radiation intensity can also be expressed in terms of the average power, where it is equal to omega by 4 pi. So this is what we call it as radiation intensity. And the radiation intensity is also one of the important parameters which also helps us to know about the directivity. So the next term what we are understanding is directivity. The directivity is defined as the radiation as a ratio of maximum radiation intensity in a given direction from the antenna to the radiation intensity averaged over all the directions. Directivity is nothing but, actually it is a ratio. The directivity is important in terms of the antenna. As discussed in the earlier sessions, an antenna system will have a transmitting antenna and the receiving antenna. In the transmitting antenna, there is an input source which is being given, and the source what is there, that will help the transmitting antenna to radiate power for the generation of the transmission of the information. And this is what we call as radiation intensity, maximum power radiated from the antenna. So when we are defining the directivity also, we take the ratio of this, the ratio of the output by the input. So the output and input is relevant to the radiation intensity. So directivity is defined as the ratio of radiation intensity in a given direction from the antenna, because the direction is the important parameter for the radiation to take place, whether it is placed in H plane or as E plane or as whatever the angle it has been aligned. So that is the purpose why we call it as radiation intensity in a given direction from the antenna to the radiation intensity averaged over all directions. Here we are assuming the condition that the source which we are using is an isotropic source. So as it is an isotropic source, we take into consideration that the power is radiated uniformly in all the directions. That's the reason why directivity is defined as the radiation intensity, that is maximum radiation intensity divided by its average radiation intensity. And always the average radiation intensity is equal to the total power radiated by the antenna, which is divided by 4 pi. And whenever the direction is not specified, then the direction of maximum radiation intensity is always an implied value. And if you want to define the directivity for an isotropic source, then the directivity of a non-isotropic source is equal to the ratio of its radiation intensity in a given direction over that of an isotropic source. So this is the formula for directivity in terms of radiation pattern, where the directivity D is equal to U divided by U naught, that is the radiation intensity in a given direction divided by the overall radiation all the directions. So it is D is equal to U by U naught. And by the second equation, it has directivity is equal to 4 pi into U, and the total power that is available by all the directions is power radiated. So we can derive the value of directivity by means of the equation. Either it will be given in terms of radiation intensity or else it will be given in terms of power radiated. So if it is given in terms of radiation intensity, then it is the equation is U divided by U naught. If it is in terms of power radiated, then it is 4 pi U by P radians. The RAD means to say that the power radiated. So this is the final equation to derive the directivity. That is, if the direction is not specified, means suppose if you are making use of a non-isotropic source. Under that condition, the directivity of an antenna, when the direction is not specified, it shows that the direction of maximum radiation intensity can be expressed as 4 pi into U max divided by power radiated. And always the directivity is a dimensionless value. In the lab also, you'll be finding out the gain and directivity of the antenna. The gain, you'll write it in dB, but directivity, there is no unit for directivity. And D naught here in this equation is maximum directivity, and U is radiation intensity, that is watts per unit solid angle, and U max is maximum radiation intensity, and U naught is radiation intensity of isotropic source. And PR stands for total power radiated. There would be simple problems asked on directivity. So this this formula has to be remembered. That is, D max is equal to U max by U naught, or D max is equal to 4 pi U max divided by P radians. That is the power radiated. PRAD stands for power, the total power radiated. Next, the directivity also can be explained in terms of the angles, that is theta and phi. So here the directivity can be expressed in terms of the angular space by the equation D is equal to U into theta by comma phi divided by U naught, or it can also be as written as 4 pi U into theta comma phi divided by total power radiated. And if you want to know what is the maximum directivity of an antenna, then the equation what we use is P by P pi into U max divided by total power radiated. So this is about directivity. So always the directivity is a parameter which is related to the radiation intensity. And coming for the value of radian and steradian. What is radian and what is steradian? Because this is one of the important dimension value to be expressed for a antenna. So what is radian? A radian is a unit which is used to measure the plane angle. That is, one radian is defined as the plane angle with its vertex at the center of the curve. So, if this is the area, total area of the isotropic radiator, then this is the radiation per angle and the resultant field is R. Then it is expressed as C is equal to 2 pi R, or I can also call it as radiance is equal to C by R, where C is equal to 2 pi R divided by R. So total radiance is equal to 2 pi. Means it is the radiance, it is the unit which is used to measure the plane angle, and where one radian is defined as the plane angle with its vertex at the center of the curve. And if you want to express the value of radiation intensity in terms of steradian, then the steradian is used to measure the solid angle with its vertex at the center of the sphere. This is the whole entire sphere. At the center of the sphere and the radius r. And also, steradian is used to subtend the spherical surface area, which is equal to that of the square with each side of the length r. So you can see this is the total spherical surface and the equivalent area in terms of square is r square, which is the elemental surface. So it is expressed as d ohm, that is dA divided by r square, which is elemental surface. And d ohms is equal to sine theta d into sine theta d phi in terms of angle theta and phi. And always the value of theta lies between 0 to pi and phi lies between 0 to 2 pi. So this is the unit, that is radian and steradians are the units used to express the radiation intensity of an antenna or its radiation intensity of a source. And always one steradian is equal to 3283 degrees. That is one steradian. Steradian is expressed as SR. So one steradian is equal to 1 radian square, and 1 radian square is equal to 180 divided by pi whole square, which is expressed in degrees. And finally, I can write 1 steradian is equal to 3283 degrees. This unit you should know because these values can be asked in objective questions. So 1 steradian is equal to how many degrees? It is 3283 degrees. So this is all about the radiation intensity and directivity of an antenna. So radiation intensity is defined as the power radiated from the antenna per unit solid angle, which is expressed as U is equal to R square into maximum power radiated. And secondly, the directivity of an antenna is defined as the ratio of radiation intensity in a given direction from the antenna to the radiation intensity averaged over all directions. And the average radiation intensity is equal to the total power radiated by the antenna divided by 4 pi. So the formula which we use to find out the directivity of an antenna is D max is equal to U max by U naught, or it can be expressed as 4 pi into U max divided by maximum power radiated if we are calculating in terms of power radiated. And always the directivity of an antenna is a dimensionless value. The value is dimensionless. You don't have any units to express this directivity. And always the directivity focus on the angle of alignment and the total radiation intensity by the source. So always the directivity depends upon whether the source is isotropic or else whether the source is non-isotropic. So these are the two more important parameters of an antenna.